Hello everyone, welcome back to our channel. Today we focus on current electricity part 3. In this already in previous classes I have given what is the resistance. It is opposing the flow of electric current. So whenever we are using the electronic device, it may be TV, it may be refrigerator, it may be wet grinder and all these like phone and all these, we have to use the device that is called the resistance. It is controlling the electric current. And how much resistance we are using, and suppose TV, that capacity, that resistance is different. For refrigerator that is different. In refrigerators only many different capacities are there. So based on the electronic device we have to provide the resistance like 1 ohm, 2 ohm, 3 ohm, 4 ohm, 400 ohms, 4000 ohms. So like that we should provide some electrical resistance. So mostly we are using here today color coding and tolerances for resistors. So based on the color code we can say what is the value of that resistor. So when we are going through the device, when you look that resistor, we can say what is the value, how much resistance it is providing in that circuit. So but we should find out the resistance with the help of the color coding. For this is the symbol here. Device A is there, B strip B is there, C is there, D is there. When we look that resistor, it is looking like cylindrical shape, and 4 devices are there, 4 strips are there on that. But based on the colors, we can say the value of that resistance. For this, we are taking a single code like this. B.B. Roy. B.B. Roy is a great British, very good writer. Here B is the first one. This color we can take it black. Whenever it is black, digit A, this is 0. Here the digit B is 0. It is representing power of the 10. 10 power 0 is equals to 1. The next thing is the brown. Brown. This is the 1, and here also it is 1. This is 10 power 1. Then red. Red is the 2. This is the 2. This is 10 power 2. Orange. 3. 10 power 3. Then yellow. 4. 10 power 4. Then green. 5, 10 power 5. This is blue. 6, 10 to the power of 6. This is violet. 7, 10 to the power of 7. Then this is grey. Based on the color, we should say about the value of that resistance. These are we are using in electronic devices. White. 9, 10 to the power of 9. So based on this we should give this one. This is the A, this is the B, and this is the C, and this is the D. Few examples we are discussing here. Suppose they are giving green, yellow, white, and fourth one is the gold. Here fourth one is the tolerance of the device, how much limit is there, and that is the error in that code. If it is gold, that is the 5% error. If it is silver, that error is the 10%. If there is no color, that error is the 20%. But the given code is what, when we are looking that it is looking like that. But strips, if it is what I have written green means this is green color, this is yellow color, and this is the white color. Here based on that reading, it is gold, it is silver. If there is no color means that error is 20%. Here green, yellow, white, and gold is there. What is the value of this one? Here green, how much it is? 5. Then yellow is 4. Then white, 10 to the power of 9 into 10 to the power of 9. Then error is, we are taking plus or minus, gold means 5%. ohms. 5% ohms. So like that we can find out the, based on the color we can find the resistance. Suppose they are giving reverse 2300 plus or minus 10%. How to give the color of this one? This is 2 means red, orange. Here 10 square is there. 10 square is there. 10 power 2. Once again red. That tolerance is silver. So based on this color coding, we can give the value of this one. What is the use of this one? Suppose we are having one electric meter is there. We want to provide the resistance. We want 1000 ohms only. 1000 ohms. 1000 ohms means which color we can observe on that for cross checking. 1000 ohms. So here first digit 1, brown. The next thing is the 0, black. First one, second digit is over, 2 more digit. It represents the 10 power. 10 power 2 means we are getting red, and that is silver. 20% means silver we should observe. Plus or minus 20% means we can observe the silver. So we are dividing that resistor into 4 devices, A, B, C and D. A, B are representing these colors, but third one is the multiplier. It is representing the 10 power. Then plus or minus of the tolerance means limit of that one. Error is in that. So like that, anything, even they are giving the color, we can find out the resistance. Even we know the resistance, we can say in terms of the colors. Now temperature coefficient of resistance. What is the meaning for that? Resistance is depending on temperature. Suppose we are taking one material or any conductor. Here RT is the resistance at T degree centigrade. R0 is the resistance at 0 degree centigrade. Here change in resistance RT minus R0 is directly proportional to original resistance, and this is directly proportional to change in temperature T. When we are combining this, delta R is directly proportional to R0 into T. Here we are getting one constant, that is the alpha. Alpha is called the temperature coefficient of resistance. Alpha equals to delta R by R0 into change in temperature. It should be right, RT minus R0 by R0 into T. This is the temperature coefficient of resistance and unit is per degree centigrade. When we are making one device, compulsory we have to focus on the resistance, especially electronic devices. Suddenly what happens, sometimes electrical energy is converting into heat energy also. At that time what happens, that resistors and other devices we should focus. So everything we have to study on this. So now we have given relation between temperature and resistance. Here one constant you are getting, that is called the temperature coefficient of resistance. For different material it is having the different values. Finally this resistance is directly proportional to temperature. In the case of linear and metals, when temperature is increases, resistance is also increases. This is called the positive temperature coefficient of resistance. Suppose when we are going through the semiconductors, when we are increasing the temperature but the resistance is decreasing, those are called the negative temperature coefficient of resistance. From this we can find out RT equals to R0 into 1 plus alpha into change in temperature, also we can write it. Suppose they are giving this R1 is the resistance at T1 degree centigrade. R2 is the resistance at T2 degree centigrade. At that time the temperature coefficient of resistance we should write it R2 minus R1 by R1 T2 minus R2 T1. As usual, this is per degree centigrade. Here R2 equals to R1 into 1 plus alpha into change in temperature. So this is the temperature coefficient of resistance. Like the temperature coefficient of resistivity also we should write this alpha value. Suppose rho naught is the resistivity at 0 degree centigrade and rho T is the resistance at T degree centigrade. Here alpha equals to rho T minus rho naught by rho naught into change in temperature. The given problem is find the resistance at 0 degree centigrade. Alpha is temperature coefficient of resistance is 3.6 into 10 power minus 3 and resistance at 100 degree centigrade is the 25 ohms. Here we should find out the resistance at 0 degree centigrade means R naught we should find out. Already we know that RT equals to R naught into 1 plus alpha into change in temperature. From this R naught equals to RT is how much? 25 ohms because T is 100 degree centigrade. 25 by 1 plus alpha is 3.6 into 10 to the power of minus 3 and change in temperature is 100. Means we can write 10 square. Then R naught equals to 25 by 1 plus 0.36. 1 plus 0.36. So this is the 25 by 1.36. Approximately R naught equals to, we are getting the 18 ohms. So the given data is, we know the resistance at 100 degree centigrade alpha value and we can find out the resistance at 0 degree centigrade. From this you are getting this is approximately 18 ohms. Then one more problem we are looking. Find the change in temperature. Same formula we are using. Find the change in temperature. But if the increase in temperature is in resistance is 10%. Look, we should consider R2 equals to, otherwise RT equals to R naught plus 10%, 10 by 100 times of this R naught means 110 R naught by 100. 1.1 R naught. And initial temperature is the 0 degree centigrade. And here we can find the temperature or change in temperature also same because initial temperature equals to 0 degree centigrade. So we can take this formula RT equals to R naught into 1 plus alpha into change in temperature. Then substitute all values 1.1 R naught and this is the R naught 1 plus here alpha is 3.92 into 10 to the power of minus 3 and change in temperature delta T. This R naught cancel. So 1.1 when we are sending this is minus 1 equals to 3.9 into 10 power minus 3 into delta T. From this delta T equals to 0.1 by 3.92 into 10 power minus 3. Approximately we are getting this value is the 26 degrees centigrade. So based on the given data we can find out the initial resistance or resistance at T degree centigrade, temperature coefficient of resistance of particular material.